Hello, mathematicians. Today we're going to look at how we can use our derivative rules to make finding limits easier. So remember, our limit definition of a derivative is f prime of x equals the limit as h approaches 0 of f of x plus h minus f of x divided by h, or the derivative of a function at a point is f prime of a, so where a is the x value that we're looking at, limit as x approaches a of f of x minus f of a divided by x minus a. So our steps to use our derivative rules is we first have to identify what is our function that we're looking for, at what x value, if that applies, and then we can evaluate the limit using our derivative rules. So let's look at this. We have the limit as x approaches 4. That tells me, because I have x approaching 4, I'm going to be using my second definition. I'm going to be finding the derivative of a function at a point. So I look at this first part, and that's going to be my function. This is my f of x. This here is telling me what my x value is. So I can say f of x equals 0.25 times x to the 4. We want to find the derivative, f prime of x. To do that, we're going to use our power rule. So we're going to bring our constant to the front, times 4, bring our exponent to the front, x, and subtract 1 from the exponent. 4 minus 1 is 3. So if we simplify a bit, 0.25 is a fourth, times 4 is 1, so these cancel. We're just left with x to the third. Now we're evaluating at x equals 4, so f prime of 4 equals 4 to the third power. 4 to the third power is 64. Let's try another example. Here we have the limit as h approaches 0 of ln of x plus h minus ln of x divided by h. Here I have h, so this tells me I'm going to be using my first definition. And I don't have a specific x value here. So what's my function? Well, I'm looking here for f of x. So this part here, not including the negative, is my f of x. And what's the derivative of ln of x? Well, it's f prime of x is 1 over x. See how much easier it is when we're using our derivative rules? But you always have to make sure that the definition is applying. So we have f of x plus h. So if I put instead of x, x plus h, I would get my beginning part minus f of x divided by h. So I'm applying my derivative limit definition. Okay, let's look at this next one. Here I see h approaching 0. So I'm going to be using my first one. But if I'm looking here, I don't see any x values. So this must mean this is my function evaluated at some number. Well, what could that number be? So I'm going to look here. This will be my f of x plus h. So I see here my plus h. That must mean x is 1. So x must be 1. So my function, I can just take out that h. F of x must be the square root of x to the third power. So now we can take our derivative. F prime of x, actually, before we can take our derivative, we need to rewrite this. So when we have a square root, there's an invisible 2, and it's give a hoot, it's the power divided by the root. I always have to say that to make sure I don't mix up which one comes on top. So we have x to the 3 over 2. Now we can take our derivative using our power rule. So we bring our exponent down to the front, and we subtract 1. 1 we can rewrite as 2 divided by 2. So we're going to have 3 over 2, x, 3 minus 2 is 1 over 2. So we can rewrite this using our square roots. 3 over 2, square root of x. But now we have to plug in 1, because that is our x value. So we have 3 over 2, square root of 1. Well, the square root of 1 is just 1, so that's just 3 over 2. Now to double check that we have this correct x value, if we plug in 1 into our original function, 1 cubed is 1, square root of 1 is 1, and that's why we have that 1 there. Let's look at the next one. Limit as x approaches 0 of sine of 2x divided by x. So here I have my x approaching 0. That must mean I'm using my second definition here, the function at a point. What is my point? It's whatever x is approaching. My f of x is whatever is first. So x equals 0. And whatever's first, I actually don't have anything else here. So this is my f of x. And let's double check. What's f of 0? Well, sine of 2 times 0, that would be sine of 2 times 0 is just sine of 0. And sine of 0 is 0. So if there's no second number here, because it's just minus 0, we don't need to write that. So we have f of x equals sine of 2x. F prime of x, we're going to take our constant to the front. Derivative of sine is cosine, and keep that the same. Now we evaluate our derivative at the point. So at x equals 0, 2 times cosine of 2 times 0. That's cosine of 0. Cosine of 0 is 1. So that's 2 times 1, which is 2. Last example. Here I have x approaching some number as well. So I'm again using my second definition, x equaling 0. And this is my f of x. So if f of x equals 1 divided by 6 plus x. Let me double check. If I plug in 0 here, I just get 1 over 6, which is what I have in the second part. And x minus 0 would be on the bottom. So now let's find our derivative, f prime of x. What rule will we have to apply here? Well, we are dividing, so let's use our quotient rule. Low, the bottom, d high, the derivative of the top, derivative of 1 is just 0, minus high, the top, times the derivative of the bottom, d low. Derivative of x plus 6, derivative of 6 is 0, and we have this invisible 1 in front of x, so derivative of x is just 1. Divide by 6 plus x squared. So if we simplify this, 0 times anything is 0, minus 1, and we have 6 plus x squared. Now let's evaluate this at our point, at our x value of 0. We get negative 1 divided by 6 plus 0 squared. So that's negative 1. 6 plus 0 is 6. 6 squared is 36. I hope that explains how you can simplify your life when you have to find something that is in the format of a limit definition. So if you see something crazy like this, it would take a lot more time to find the common denominator and multiply that out than to just use our quotient rule. So good luck with that and have a wonderful rest of your day.